Thanks very much, and really thanks very much to the organisers for an amazing conference so far and for the opportunity to give this talk today. It's my first week in Australia as well, so it's been a very welcoming experience to land into such a nice conference. So thank you all very much. As Alex said, I'm over in Galway on the west coast of Ireland. I work in the university, and some of our projects we work with local companies, one of whom is Oracle. You see them just barely mentioned in the bottom left corner there. Oracle are a small company in Ireland that actually work with a lot of professional sports teams, and their links to the statistics departments allows people like me to get great access to kind of inner data, you know, like Robert gave a lovely talk on the kind of data that's published online, the performance data from games, but some of the stuff I'm going to talk about today is the data that happens during the week before the game happens. So my talk will just describe some of the data that we have for this project and motivate the idea behind our model and subsequent application. So GPS data is measured using these devices, about pretty small, and they slot nicely into a jersey, or they can be worn with a strap. And these GPS data are measured on every player every day when they're in training. So for example, we can talk about soccer, which is, I think, the data that I'll show later on. And in that case, you know, they just slot it into the jersey, and they run around, and these GPS variables measure how far they've run, and the kind of number of accelerations and things like that. The two biggest companies actually link together, Ireland and Australia, which is nice for today. Catapult are probably the biggest manufacturer of said devices, and they're based in Australia, and StatSport are based in Ireland. And so they're kind of in a bit of an arms race about the number of variables that they tell you they collect. You know, one will say that they've got 100 variables, and the other will be like, well, we've got 105 now on the newest one. And then, oh no, we have 110. So there's a bit of an arms race going on, but underlying that is just different ways of breaking up the same thing. There's probably 5 things they're measuring, and they're just calling it different things. So you'll see that later on. So the data are structured in a kind of hierarchical sense. So just a bit of kind of, I suppose, defining what these things are. Training session, or a session is, say, a day's training that they've done. And within that session, they'll do numerous drills. Could be 5 or 6 drills in that training session. So drills can be things like a warm-up drill, or a conditioning drill, or a tactical drill of some kind. And there's lots and lots of different drills. There could be 150 drills across the season for a soccer team. And not all drills will be run by all players. And so what we see is multiple observations from lots and lots of drills for lots of players. And these data are nice, and they get lovely summaries and stuff. And when we came along and we were working with this, we were actually building out some data visualizations to allow the teams and the sports scientists themselves to interrogate their own data, to look at the past training data, to kind of, and they really were just eyeballing kind of ggplot curves and saying, you know, that makes sense. That's when your man got injured. You know, there wasn't any objective stuff going on. So using that idea of all of this retrospectively collected data, we came up with the idea to use it to allow the sports scientist or coach to plan tomorrow's training session and get some idea of what might happen in terms of GPS. And also to be able to say a certain amount of GPS and try and choose or choose which drills might get you to that level. So if you want them to run 8 kilometers tomorrow, tell me how to do that. So modeling, I'll get into a little bit. I suppose we're probably all familiar with all of this stuff, but it kind of varies by sport. So when you have an individual sport like tennis or golf or whatever, then you can just use perhaps a simple regression model where I here indexes the instance of the drill. So if you have Andy Murray doing a drill 100 times across a year, then you'll have I of 1 up to 100. And we just simply fit a linear regression model that looks something like that, and then we just make predictions off that. In a team sport, which is kind of represented here as a toy example, you have 3 different players there. You've got a blue player, a green player, and a red player. And you can see that their distances as the length of the training session, that's our drill, is increasing. Some of them are going up over time. Some of them are, when they know that the drill is going to go on so long, maybe they don't run as much. Okay, so they're going down. The green player there is going down. And in that case, a linear regression fit isn't going to be great because you're going to have quite large residuals. So The idea then is to use a mixed model, also known as a random effects model or a multi-level model, and also a mixed effects model. So all of them are the same thing, and they involve just allowing individuals to have their own trajectories. So it's a very similar model as the last one, but now we've just got a little index on there, an extra j in there, and beta 0i is individual i's intercept, and beta 1i is individual i's slope. So we get individualized fits to the data, which are estimated using the variance of these guys. So these are the random effects. U0i will be that in that case, that green player's intercept is a bit higher than the group average. So that would be a positive number. But the variance, which is what is estimated, will be determined by the size of these things. So if everybody had the same intercept, then the variance would be equal to 0. And if everyone had the same slope, the variance of the slopes will be equal to 0. And that's what we see here in the random effects matrix at the bottom. You're estimating sigma squared u0 as the variance of the intercepts, which would be very small if they're all the same. And similarly, u1 is the slopes. So these allow us to get individualized predictions from them and reduce the within subject error down to these individualized EIJs. So that's just modeling the data in a very simple case, but what we see when we looked at the data themselves for different outcomes, I think I skipped over that, but amongst those hundreds and hundreds of outcomes, we're running a model for each outcome. Okay? In some outcomes, the data were nonlinear over time. So in that case, you might think of things like maximum speed. You know, the longer they're out there doesn't necessarily mean they're going to pull off a 50-kilometer run just because they've been out there long. If you think about it, the longer they're out there, they might not be sprinting as much. So the longer the drill is being run for, it might go down over time, and we might see nonlinearity. So we build that into the model using splines. And another nice thing that we've worked on is kind of clustering together similar drills. So if we have 150 drills and 100 different outcomes, then that's a lot of different models, okay? Which is not too good. And what we'd like to do is maybe combine different drills together, okay? And we can combine different drills together in a couple of ways. We can simply look at the naming of the drills, and these are controlled by the sports science staff in a team. So it can get a bit messy. But for instance, in this case, small-sided game SSG is very similar to small-sided game 8v8 and 7v7, so they're probably quite similar. So we look at those and see if we can cluster them together. Then, using more of a kind of statistics approach, we can look at summary statistics for each drill and just combine and contrast different drills and group together very similar ones in terms of outcomes. The other things that happen in sport is that you have data that change over time. So in professional sports, if you're not doing so well, you're going to end up with a new coach. And if a new coach comes in and you have 5 years of data collected from the last coach, it's a bit of a bummer then, you know, what are you going to do? So if that new coach was promoted from inside the organization, maybe they were an assistant coach, then they might use a lot of the same drills, so you're okay. If it's a completely outside coach, the best thing to do to use all the previous data is to just have an indicator variable in there for coach. And in the case of a new coach, they're going to have a lot of new drills. So if you carte blanche have all brand new drills, then the model's going to take a little while to make any kind of useful predictions. So what we do is we look at the first few instances from a new coach and see how that compares to the last coach on the same players. And then we can kind of group together similar drills to add to the power of prediction for those new drills from the new coach. In a very similar way, for new players who may have just come through the academy or perhaps they've been brought over, those new players don't have any data for all of these previous drills. You've got 20 people who've run these drills many, many times before, and then you have a new person come in. So what do? Do you just say, let's wait and build them up a little bit? Or after 1 or 2 drills, you could start with which position he or she are in. But after a few drills, you can try and match them to a very similar player in the squad for whom you have 4 years of data. And again, that adds to our power of predictions going forward. So the data that I have to kind of demonstrate the performance here are from 3 different professional sports teams, and international teams actually one of them is. And they range in the player sizes from 24 up to 47. We have a maximum of about 139 drills there for one team, and that's in a period of 5 months. So you can see that whatever coach that is likes to shake things up a bit, okay? So you have lots of different drills, and the number of data points actually isn't massive, okay? So we get a data point when a player runs a drill, and we have a maximum of about 2,100 there for that team. And then you can see evidence of the arms race over on the GPS variables column. So this is one of the devices saying we have 190 different variables for that drill. You know, it could be 5 minutes of running around the field and they'll give you 150 different variables to describe what happened in those 5 minutes, you know. This is broken down by, they have like different zones. So they'll have impacts, and they'll have impact zone 1, 2, 3, 4, 5, and 6, and 7. But then later versions will have up to 9 zones and so on. So it's very similar data. In terms of prediction, what we did was obviously break up the data into a training sample and a test sample. To do that randomly was a bit erroneous sometimes because the drill had not been seen before. So what we did was we removed those players who had the most data and removed them from the sample and used and tried to test on them as if they were new players coming into the squad. And we measured across 6 different metrics just to kind of keep it simple. We have distance, acceleration, and training load in different guises there. And then we used all of the other players to build a model, prediction model using clustering, using the nonlinear approaches, and based on the linear mixed model framework. And then we predicted their training load across all the drills that we had for them. And we looked at the correlation between the predicted and the actual training load. So sorry for the small font there, but what we saw in general was that we got pretty good predictions. The predictions are on the x-axis and the actual data are on the y-axis. So we got very good correlation and very small median differences between actual and predicted load. That was also true for accelerations, which is more of a count variable, so you have 1 or 2 or 3 or 50 accelerations. And again, we're getting pretty good predictions for those individuals. And again, in training load and explosive distance, which is a very exciting sounding variable, but explosive distance, or dangerous, depending on how you're thinking, you know, gives us, again, we're doing pretty well, and that's good. And there's a number of teams using this across, there's one in the Premier League, and there's a couple in the NBA as well who are using this at the moment. And we're really still in the Shiny app stage, you know, of building this in Shiny. We may work on a kind of more production level variant, but I mean the Shiny one is going very well. So while I'm at the user conference, obviously I'm going to say keep it going with the Shiny. So this is a view full screen. A simple mock-up, or sorry, this is the actual app itself on some dummy data. And it's just a Shiny dashboard thing. You can kind of choose the number of drills that you'd like to do first. So the idea here is that I'm sitting here today and I'm thinking about planning tomorrow's training session for my team. And I want to find out, like, you know, how far they're going to go tomorrow. So I say, right, we'll keep it simple because we can fit it on the screen there. That's not, I type 2. And so you have 2 drills, and then you can choose the type of drill. So some of the teams come along with this kind of parented version of drills. So they have like groupings, all of these different warm-up drills, and all of these ones are conditioning drills. Whereas other teams will come along and just have the different drill names. So here, let's say we do a recovery drill because of what happened last night in the State of Origin game, for example. That was pretty brutal. I was down there. That was a great thing to organize for user, fair play. And let's do some head tennis. So we've got head tennis going on here, which is a fun sounding recovery drill that we'd all probably like to do. We can choose how long that goes on for. Let's say we'll make it kind of short, but we'll make them do it 10 times. And then what we have on the right hand side is an option to choose whichever metric we have, these are the kind of outcome variables. So we have distance, but we also have kind of distance broken up into jogging speeds and walking speeds and so on. And then we can see a drill by drill breakdown of said events. So you get a prediction of 676 meters with some uncertainty around it. So there was some clambering from the colleagues who are more in the machine learning and come from a computer science background about including uncertainty. But as a statistician, I would always like them to see that, you know, because then you're setting yourself up for a fall if you're exact. So we have these drill by drill breakdowns, and we also scale it to a match. So we also have game data in the Premier League because they're allowed to wear the devices, or it's measured by camera. Okay, and if we're interested, we can save this session to the database. Okay, let's just go with. Okay, and then what we can do is put, oh well, it was working on my computer as the classic line. So anyway, the teams hopefully don't go through this when they're working away over in England and in them, but what we can do then is pull up a saved session. Here's one I prepared earlier. Is it going to be able to access it? Yeah. Okay, and then we can kind of pull on a few different variables that we'd like to see, and we've given them a nice breakdown of those things, although time is pretty boring, that shows that. And then we have a nice little kind of Google Maps style printout that they can have download as a HTML and bring onto the thing, or just have it on their iPad when they're standing on the side of the pitch. So that's it from me. Thanks very much for listening, and if anyone has any questions, I'd be glad to hear them. Yes?
Has any work been done to extend this to forecasting injury as a result of training?
No, this is a separate project around injury modeling that I'm actually working on with people in the University of Wollongong. So I'm hoping to visit them in 2 weeks. But you know, I could talk about injury modeling for a long time. What would happen in a lot of Premier League in teams is that you wouldn't have many injuries, and so that would be something that we would like to build into this. You know, if you could come up with warnings for patterns of training load which have led to injuries in the past, and just alert the staff to the most similar pattern. When you have had an injury, if you've got a pattern coming up which is similar to before that injury, then that could be something we could do in a simple summary statistic sense. The hardcore injury modeling within sports science is a kind of lots of people are trying to do it, and I think we need to kind of start again and think about building models and finding associations. The papers in that space tend to immediately build a prediction model. You know, that's the first thing they do. And you know, if you think about medicine, people don't immediately build risk prediction models and have apps and stuff. You know, they do hard research and try and find out what's related to the disease, in this case, what is related to injury, and then do studies later on. So I would say we're going down that route. Yes, Di.
What happens if, say, the bionic player showed up with some completely different performance pattern? Would that affect your model?
Absolutely, yeah, it would. It would. You would look at that person, but if you have enough other players, then the overall fit will be not too different. The random effects model, as I said, doesn't estimate each of those lines separately. Okay, we do have an option in there to drop outliers from the data. Whether that player would be classed as an outlier is different, but that says outliers in terms of the data, because if someone hits one of the devices, it can say, oh, that was 10,000 accelerations, because it's rattling about, but it's not. So that's remove outliers. So in that case, we could have a remove outlying player button. So that might be a nice idea. Yep.
Do these devices update in real time? And if so, do teams use it to, say, identify players that are tiring in-game or in training?
Yeah, that's a very good point. The data we've seen so far is not. It's offline. Teams are, as you would imagine, scared of data being hacked, I suppose. So data being transmitted live You know what, we've built like apps for questionnaires and stuff, and they're like, well, we're going to be doing this on the court, and they've got cameras in the away thing, so you know you can't make the words too big. So they're very data secure, which is great. You know, we all should be more now. But that would be nice to see it on the fly. If they had a closed system on the side of the pitch, that's an idea to do that for sure. Currently, they plug in the devices. They get a big briefcase and have all of the players, and they take off all of the things and just plug them in and plug it into a laptop. The data goes there.
I might have to make this one last. Sorry. Just last one.
Sorry. Have you tried a Bayesian approach when you have a new player or a new coach? Or you mentioned that you added them as an indicator variable. Have you tried a Bayesian approach to a new player?
No, but you're very right. That would be a really good idea, and one we hadn't looked at. Yeah, it makes perfect sense, really, if you think about it. You could have a prior based on that position that the player comes from, and inform then your predictions based on that. So that's something we could tackle, you know, if we find things that aren't going so well. But the transitions between players and drills might also help the Bayesian approach. So that would be a good idea. Thanks. Okay.
Well, thank